Hello guys, and welcome to my redgame 2 work in progress video. So, well, first of all, everything's now stacked on top of each other. There's a graphics card in a small room. Control panel's also simplified, buttons are closer and stuff. Also, as you can see, there's buttons to turn it on and off, so the computer can now actually turn itself off, which is quite handy. Now, a lot has changed in this version, basically because I rebuilt the entire thing. So here's it's 32 bits, only 31 of them are used, which is the first one's disabled. The new ALU, slightly color-coded. So set number 1 and 1 in there for demo purposes later. Accessor is the registers. It's also a new system. Well, if you need to do a number, then you need to do a sort of sum, or need to use data, you have to go through the registers. Some of you suggested that I added a random number generator, so here it is. It's currently off so that the clock doesn't freeze. But there you go. It's basically a lot of clocks. I did those random number generators. Salaja used the same system. It's compact, it's not that noisy. ALU controls and stuff are all at the top floor. RAM, controllers and shit. Okay, so how the system works is now everything goes through the registers, and you can't load from these registers, only from these registers. So these are the loading registers, and those are the save to. So if you need to do a sum, you need to save to register 1 and register 2, the two numbers you're going to use. Now, you cannot save from a register to another register. So this, save from here to here, it has to go through the RAM. However, you can save from RAM to RAM, which is what this thing's for. The data bypasser. It's basically wires that go back up here. There's many other technical reasons why you can't move from register to register. So, anyways, that's that. Also, many people suggested I do vertical busing. It's up. It's all these wires here. Seriously annoying and confusing. All over the places. There, there, there's one here, there's one there, there's one there, there's one there, there's one there, there's one here, there's one there. Yeah, basically everywhere, yes. Now, this thing's got many floors of wiring as well. Underground here is these register controllers. And you have these register connectors, and that thing. There you have the ALU top parts, and more register controllers. And you have wires on top of that. On top of that, the command manager. And then on top of that is going to be the program manager. Here. But it's not built yet. This is a work in progress video. Basically, the thing's entirely rebuilt. Should be faster. A lot faster. And, well, yeah, it looks cooler. Smaller, should be less laggy. It's faster, it's got more memory. It's my second attempt at a computer. Okay, now there's probably haters out there going, it's fake, nah, it doesn't work, liar. Just put lots of pieces together to make it look cool. But I'm going to try and show you how it works. Now, I haven't done much debugging on this computer. In fact, I've hardly done any debugging at all. So I'm going to hope that this works. So firstly, I already saved 1 and 1 into the two ALU registers. So we are going to add, that would be 0, 0, 1, 0. Now this then sends data all the way down here. Selects the command. It goes into the ALU. So now it's computing. Well, it's computed already. It's really fast. So it's outputted here. Currently nothing's happening here because we're not loading from it yet. So we're going to load this. We're going to read the answer. To load the answer, I think this is the loader. That should do it. because it's the first register we're loading from. Now, the data's on this bus. Right there. The number 2. Okay, now command is this obviously faster and all at the same time. It's just for showing I'm flying over to see everything. So you can see how it works. Okay, so now we need to save this value to RAM. Select the RAM. Now this over here selects whether we're saving to a register or to the RAM. So, yeah. If we're saving to a register, then only these 3 bits apply. These 2 bits are only read if we're using RAM. Now, we're going to save to RAM. So first bit of RAM, it's RAM. Save. And now, we should have saved it onto the RAM. It should be there. It could possibly not work, or not have worked. I hope it did. So now we're going to load from RAM. It's precisely the same RAM place. And now, at the bottom bus of the register, we should see number 2 inverted. It's not there. It's probably something wrong with the RAM. Okay, so anyways, usually the data comes onto these lines, runs all the way along here, and then you can save them to another register, like the ALU register, or to the RAM again, or to the graphics card, and stuff. So yeah, hope you like my progress, and I hope I find out what's wrong with the system. So thanks for watching. Sorry guys, I forgot to tell you one thing, the new command system. So it's 34 bits now, and it's to improve speed even further, it does 3 things at the same time. That's go to, RAM functions, and mode functions. All 3 of them at the same time. So here's the 6-bit if 0 else go to system from the previous computer. I'm keeping this because it's just so awesome and useful and powerful. It really is pretty cool, even though it takes up quite a lot of space. So here's the save to RAM. It's both registers and RAM. This one decides whether it's registers or RAM. The load from RAM, same here, if it's RAM or register. So you can move around register, from RAM to registers, move around RAM, kind of thing, while you're executing or changing something on commands, because now everything is basically computed from the registers. So if you're doing an ALU math sum, the command would be to change the math it's currently doing. You don't have to use this. If you set it to all 0, it won't do anything. No, wait, it'll set the ALU command to 0, and whatever. You could just keep it on the previous command, then it won't do much. Unless it's a graphics function. And the go to read value. This I've implemented because I thought it might be useful. So this is what it reads. If it's a user input switch that affects the go to over there, or the ALU if 0 else, or if the random number generator is on, because you can change that from the control panel, you probably will. Not sure if I am going to do that. Anyways, you can do that from here. So now use the go to system even more. This is not too final, at least I don't think it's that final. It's my design, it's a very rough draft design. Came up with it while I was supposed to be sleeping. So yeah, it's divided into a few sections. 1, 2, 3 sections. So, well, if you have a better idea for a control system, because remember, I'm trying to make this thing as fast as possible, then send me a message or leave a reply, something. Try to contact me. Okay, so again, thanks for watching. Hope you like it.